Hi dosto, my name is Dr. Subhasish Roy. Today I am going to deliver some concept from organic chemistry chapter, which is aldehyde, ketone and carboxylic acid. Okay, so let us start. What is aldehyde, ketone and carboxylic acid? So as I have shown here, aldehyde and ketone both belongs to carbonyl compound, where this CO group is common in carbonyl compound. As we can see, in all these cases this carbonyl bond is present. The difference between aldehyde and ketone is that in aldehyde there is at least one hydrogen present. So as we can see here, two hydrogen is present, so this is also aldehyde, but only one hydrogen should be present, then we can call it as aldehyde. And if there is no hydrogen, then we can call it as what? Ketone. In this case we can see here R1 and R2, where R1 and R2 is alkyl group or aryl group, so there is no hydrogen, so this is called as what? Ketone. Okay, so now both these aldehyde and ketones are called as carbonyl compound, which is having this carbonyl group common. Now next let us come to carboxylic acid. Carboxylic acids are organic acids. As we all know that inorganic acids are very strong. For example, hydrochloric acid, we know it is very strong. Nitric acid, it is strong. But organic acids are not very strong, they are weak. For example, we know that acetic acid, CH3COOH. So this is called as what? Acetic acid. And this 10% of this acetic acid is called as what? Vinegar, which we can also eat. And also it is used for malination and other purpose. So we can tell that this acetic acid is not harmful because this is a what? Organic acid. So this carboxylic acid has this general formula of RCOOH. Now if this hydrogen is replaced by an alkyl group, then we call it as what? Ester, RCOOR. RCOOR is ester. Now if this OH group is replaced by a chlorine, then we call it as what? Acid chloride. And when this OH is replaced by an NH2 group, we call it as amide. And when this OH group is replaced by an acetyl group, then it is called as acid anhydride, which have the general formula RCO whole twice O. So this is called as acid anhydride. So these are all nothing but what we call it as what? Derivative of carboxylic acid. That means, what do you mean by derivative? Derivative means these kinds of compounds can be prepared from carboxylic acids. Okay. So next we move to next slide. So now how will you prepare these carboxylic acids in the laboratory? Okay. So as we know that alcohols having this formula RCH2OH. Now if you oxidized alcohol, then first we get what? Aldehyde. Okay, so first we will get aldehyde, and then if you carry out further oxidation, then we get RCOH. That is called as carboxylic acids, right? So now we are discussing about the preparation of aldehyde and ketone first. So what we came to know is that if you use a weak oxidizing agent, we can stop the reaction up to aldehyde. But if you use a strong oxidizing agent, that means 2 times oxidation is occurring, 2 times, then we can come to what? Carboxylic acids. So this alcohol, if we use a strong oxidizing agent, then we will get carboxylic acids. And if we use a weak oxidizing agent, we can stop the reaction up to this aldehyde. And in fact, we need these kinds of weak oxidizing agent. And PCC is called as what? Pyridinium chlorochromate. What is PCC? PCC means pyridinium CHLOR chlorochromate. This is a weak oxidizing agent. This is a weak oxidizing agent which can stop the reaction up to aldehyde. Now you can see what is oxidation. Do you know? So oxidation means what? The definition, the simple definition which you have already studied during class 10 class is addition of oxygen simply, or another words we can also tell that oxidation means what? Removal of hydrogen. Now in this case you can say that CH3OH is forming HCHO. So definitely there is what? No addition of oxygen. But there is here, you can tell that here this formula, if you see how many carbon it has, 1 carbon. How many hydrogen it has? 4 hydrogen, oxygen. Now here how many carbon it has? 1 carbon, 2 hydrogen and 1 oxygen. That means here it is nothing but what? Removal of hydrogen is occurring. So we can call it as what? Oxidation. So methanol, when it is oxidized with pyridinium chlorochromate, which is a weak oxidizing agent, we can stop the reaction up to aldehyde. Similarly, this ethanol, if you oxidize with pyridinium chlorochromate, you can stop the reaction up to what? Aldehyde, that is ethanol. Now these kinds of alcohols are called as primary alcohol. So when primary alcohol is oxidized, you always get what? Aldehyde. Now let us come to the secondary alcohol. You can see what is secondary. Here you can see this carbon is attached to 2 methyl group. So it is called as a secondary alcohol, or also we mention it as 2-degree alcohol. So when this secondary alcohol is oxidized, here also 2 hydrogen will liberate, then you will get a what? A ketone. So this you always remind that primary alcohol oxidized to aldehyde, while secondary alcohol oxidized to ketone. Okay. Similarly, you can also see that when there's hydrogen is, it should not be there, it should be H. Anyway, when there is this removal of hydrogen, then we get as what? Ketone. For example, let me to explain and once again with the help of one example. Suppose this is CH, this is O, this is H. Now when this hydrogen will be eliminated, then this electron and this electron will make a bond. You will get a what? Ketone. And this hydrogen will be going out. So it is oxidation. Okay. So let us move to the next slide. So primary alcohol on oxidation gives aldehyde, while secondary alcohol on oxidation gives what? Ketone. So what is secondary alcohol? When carbon of the OH group is attached to another carbon, then it is called as secondary alcohol. So now this reaction is a famous reaction. It is called as Rosenmund reaction, where we can see that this acid chloride, this kinds of compound is called as acid chloride. As I already discussed with you, this acid chloride is nothing but a what? It is a derivative of carboxylic acid. So this is carboxylic acid. when it is treated with thionyl chloride, then you will get this acid chloride derivative, which is CH3COCl. So this is also known as acetyl chloride, or also it is called as acid chloride. Now this acid chloride, when it is reduced with hydrogen in presence of palladium on barium sulfate, then we will get what? CH3CHO. Now you can see clearly, in this case you can see clearly that here there is a chlorine. So this chlorine is what? This chlorine is replaced by what? This hydrogen. So what is happening? This hydrogen and this chlorine will combine to form HCl. Now you can clearly see that in this case this chlorine is going out and hydrogen is coming. So it is nothing but a what? Reduction reaction. Clear? So these kinds of reaction is called as reduction reaction. Clear? So another example I have shown you. Here also you can see this chlorine is replaced by hydrogen. So we can call it as reduction. But one important point is that already I have mentioned here why palladium barium sulfate is used in this case. You can ask that also, that if we carry out the reaction with suppose hydrogen in presence of active palladium, the reaction will happen or not? Yes, the reaction will also happen with this what? Active palladium. But here this palladium is so much active, this is so much active that it can carry out what? Further reduction to form CH3CH2OH. Then instead of getting this aldehyde, you end up with aldehyde and alcohol. So you will get two products, but in organic synthesis we need only one product, that is called as selective reaction. Selectivity is a major concern in organic synthesis. So if you want to synthesize aldehyde from acetyl chloride, selectively we use this palladium barium sulfate, which is slightly deactivated catalyst. That means this reaction can be stopped up to only aldehyde. No further reaction can occur with what? This palladium barium sulfate, because it is already deactivated. So as I already also mentioned here, palladium barium is a slightly palladium on barium sulfate is a slightly deactivated catalyst than palladium carbon for reduction of acid chloride. It can stop the reaction up to aldehyde, and if activated palladium catalyst is used, then acid chloride will be converted to primary alcohol, which will be a drawback. So we can use this palladium on barium sulfate. So let us go to the next slide. Then this is also a famous reaction, as you have already discussed in a class 11 chapter, hydrocarbons. So this is called as ozonolysis. I am not going to discuss this topic, but anyway I will be giving some hint how to remember these reactions. So here this is called as alkene. This is called as alkene. Now alkene with reaction with ozone, which is a oxidizing agent, it can form a house-like structure. You can see it is looking like a what? House. It is looking like a house. So this house is called as ozonide. You can see this is looking like a house. So this is ozonide, right? Now this ozonide, when you react with zinc and water, undergo hydrolysis, next step this house will what? Break. You will get this part one carbonyl compound, another part another carbonyl compound. So how to remember this reaction? So first this alkene can react with ozonide to form a house-like structure called as ozonide, and then it can react with zinc and water to break the house, and you will get a mixture of carbonyl compound. Okay, so this reaction is called as addition reaction, or also it is called as ozonide formation. Okay, so you can get a different kinds of compounds. For example, in this case you are getting two similar carbonyl compound, because this alkene is what? Symmetrical. From the same site you will get two same product, but this you can see there is a different. This part is not symmetrical, this part is not symmetrical, so you will end up with two different carbonyl compound. So in one part you will end up with a aldehyde, whereas in another part you will end up with a ketone. If you react this with what? First with ozone and next with what? Zinc and water. Okay, so this is called as ozonide formation. So let us go to the next slide. So next, this reaction I will not go into details discuss about this. This is called as retard reaction or retard oxidation, where you can clearly see that this CH3 group here, this is CH3, one cleavage will undergo. Both this CH bond will undergo cleavage in presence of a strong oxidizing agent. This is called as chromyl chloride. So these two bonds will be break and you will get a what? You will get a aldehyde. So this is called as benzaldehyde. Okay. So next is also this another one reaction we will also discuss with phenol, that this phenol in presence when react with sodium hydroxide and chloroform, it can produce this 2-hydroxy benzaldehyde, which is also called as Reimer-Tiemann reaction. This already we have studied, I think, in phenol. So next, let us discuss about Getterman-Koch. Now here, this Getterman-Koch reaction is also used for the preparation of aromatic aldehyde, that is benzaldehyde. So here you can see that this benzene here, it can react with carbon monoxide and HCl in presence of anhydrous aluminum chloride, which act as a catalyst to form this benzaldehyde. And this reaction is an example of aromatic electrophilic substitution. AR stands from aromatic, E stands for electrophilic, S stands for substitution. So aromatic electrophilic substitution reaction. Here we can call it as a formylation reaction also, because this CHO group is introduced, so it is also called as formylation. Now next is a what? By Friedel-Crafts reaction. So we can see that we can prepare this ketone. This is ketone because there is no hydrogen. So this is called as Friedel-Crafts benzoylation reaction. Let us make it part wise. Here I have written combined. So this is a benzene, suppose. So what is aromatic electrophilic substitution? Let us discuss. Anhydrous means dry aluminum chloride, and here if you use suppose these types of compound which is called as benzyl chloride, you will end up with a what? Benzophenone, where two benzene ring is present, right? Now I will discuss this reaction, how this electrophil is generated. Now we can write like this. This is called as benzoyl chloride. Now this aluminum chloride is a electron deficient compound because it is containing how many electron? 6 electron. Because aluminum has 1, 2 and 3 electron in its last shell, so it can share 1 electron from chlorine, and ultimately maximum up to 6 electron it can achieve. So again it is deficient from 2 electron, which is called as what? It is electron deficient or 2 electron short from octet. We know that if 8 electron is present, we call it as octet, which is stable. Now what will happen? This chlorine will go here with its electron, because every system try to become stable. So it will generate, if this electron with chlorine goes to aluminum, then AlCl3 will become AlCl4 negative, and at the same time you will get what? This electrophile, right? Now this electrophile will what? Replace this hydrogen, and you will get the product, this. It is also discussed in class 11, so I am not going to details about the mechanism of this reaction. So next is thrice rearrangement. This is also a rearrangement, means I am not going to discuss about this, because this here you can say one hydrogen So this you can see clearly one hydrogen is going to OH, and this is coming to here. So this is coming to here, this OH is going to here. So this kinds of reaction is called as rearrangement, means within the molecules this transfer of group can occur. Now let us come to the chemical properties of aldehyde and ketones. Well, aldehyde and ketone both are called as carbonyl compound, and they have same chemical properties. However, aldehyde is much more reactive than ketone. Now let me to explain why. So this is, we call it as aldehyde, and this is, we call it as what? Ketone. Now in case of aldehyde you can see there is a plus I effect producing group. So in case of ketone there is 2 plus I effect producing group. Now here we can see that this electron can go to oxygen, because oxygen is more electronegative. So this electron cloud can be easily attracted by oxygen. Then if this electron is going from carbon, then this carbon will become partial positive charge and oxygen will become partial negative charge. So this results in the polarization of the bond. Now interesting thing is what? This plus I effect can decrease this charge of this carbon. So then it will become slightly less reactive. But in case of ketone you can see there is a 2 plus I effect group. So this charge will be what? This charge will be much more less as compared to this charge. So one thing you always remember, that if any structure contains more charge, then it is more reactive, and if it has less charge, then it is less reactive. So here you can see that as compared to ketone the charge is more, but in case of ketone 2 plus I effect can decrease the electrophilicity of carbon, because what is plus I effect? This electron cloud, it will electron donating group or electron pumping group. So this electron will pump to this carbon. So as a result the plus charge will decrease. Okay, but here in ketone the plus charge can decrease in greater amount, because 2 plus I effect producing group is present. So that's why aldehyde is much more reactive than ketone. And another thing is what? We will discuss about nucleophilic addition reaction, where nucleophile can easily add to an aldehyde, but in case of ketone 2 alkyl groups are present which are very bigger. So nucleophile will find little bit difficulties to enter, because this is called as a steric repulsion. If big groups are present, then the nucleophile will not find suitable path to enter to this electrophilic center. This center is called as electrophilic center. So this nucleophile will not find suitable path, but anyway this nucleophilic addition will occur in case of ketone, but in a lesser extent as compared with aldehyde. So the rate of the reaction will be always greater for aldehyde as compared to for ketone. So already I have explained this. Here, due to 2 plus I effect producing alkyl group, the electrophilicity decreases and hence reactivity towards nucleophile also decreases. Okay. So that's why aldehyde is more reactive than ketone. So next is what? Aldehyde and ketones reaction. So this reaction here you can see that aldehyde and ketone, if it reacts with alcohol, first it will form hemiacetal and then further reaction with alcohol it will form acetal. Here you can see that these reactions occur by nucleophilic addition of alcohol. Now you can ask that what is nucleophile? In this case this ROH is acting as a nucleophile. Why it is a nucleophile? Because any species which is negative charge or contain lone pair of electrons are considered as nucleophile. And aldehyde, you know very well, in case of aldehyde, as I already discussed with you, due to electromagnetic effect, this carbon gets plus charge, partial positive, and this oxygen gets partial negative. So obviously this R can attack to this carbon, then you will get this what? Hemiacetal. So you will get what? Hemiacetal. So this RCH, and again another molecule of alcohol will come here. Since the electron is going from oxygen, so oxygen will become positive charge, and here this oxygen will have negative charge. Finally this oxygen will take up this electron and this proton will be taken up there by this O negative, and we will end up with what? A product which is called as hemiacetal. Similarly, it can react with another molecule of alcohol by the same procedure, and again here you can get acetal. So let us go to the next reaction. This is one of the most important reaction for aldehyde and ketone. So here you can see that when aldehyde and ketone can react with either ammonia or its derivative, it can form some skip base like compound. This is called as skip base. When carbon is bonded to one nitrogen, when these kinds of linkage are there, we can call it as what? Skips base, or also it is called as what? Imine. Okay, so it is called as imine. So here this is, don't write in exam like this. Here you can consider that this H2O will go out, then you will end up with what? This double bond is there, it will attach to nitrogen and H. Okay, now this H may be any group, then suppose this N, and if H may be any group, then we get the product what? NZ. Okay, we will end up with NZ. So this is also called as skip base or imine. So as I have already discussed with you, this if Z is OH, then we call it as what? Hydroxylamine. Here also you can see clearly, here oxygen and here hydrogen will go out, and you will end up with what? NOH, that is called as oxime. Here another reaction I have shown for oxime. So here also you can see that water will go out and you will get what? This oxime product. So hydroxylamine. can react with aldehyde or ketone to form the product which is called as oxime. Obviously, aldehyde, the rate of the reaction will be faster as compared with ketone, as already we have discussed that aldehyde is more reactive than ketone. So next, reaction with hydrogen. So whenever aldehyde or ketone reacts with hydrogen is this NH2, again NH2. So everywhere, one important thing you can see that in your exam it will be given like this: hydrogen, NH2 and NH2. It will be given like this. But for the sake of our simplicity, I have taken this hydrogen in this left side, because then we can easily find the removal of water to form this product which is called as hydrazone. So when aldehyde is treated with hydrogen, you will get hydrazone. When aldehyde